All right, we're going to talk about geometric sequences in this little lesson. Hopefully you watched the video that I left for you. I'm just going to work some problems out for you. The other video goes into some deeper explanations. First of all, a geometric sequence is a sequence of numbers where the ratio r remains constant. In a geometric sequence, you are multiplying the same thing over and over and over again. To get from one number to the next, you're multiplying what we call the common ratio. Now, the common ratio, you can find it easily by taking a number in a sequence and dividing it by the previous number in the sequence. And if you keep doing that and you get the same number and over and over again, you know that you have a geometric sequence. And whatever you get when you divide, that's your common ratio. Okay? So, let's see what we can do here on 1 through 6. The directions tell us to determine whether the following represents a geometric sequence, and if it is, what's the common ratio. So if it's a geometric sequence, we should be able to multiply the same number to 2 to get to 10, and then multiply 10 times that number to get to 50, and then multiply 50 times that number to get to 250. And whatever that number is, that's called our common ratio. Okay, so in order to figure out if we're multiplying by the same thing, we're going to divide and see what we get. So take the second term and divide it by the first term, and you get 5. Take the third term and divide it by the second term, and you get 5. And then take the fourth term and divide it by the third term, and guess what? You get 5. So when I take the second term and divide it by the first, the third and divide it by the second, the fourth and divide it by the third, I'm getting the exact same value every time, okay? So when you get the exact same value, that is your common ratio. So this is going to be a geometric sequence because I am getting the exact same thing every time. Now, whatever I get, that's my common ratio. So my common ratio, which is r, is going to equal 5. So that means 2 times 5 is 10, 10 times 5 is 50, 50 times 5 is 250. So that's how a geometric sequence and a common ratio work. Now, skip this one and let's go to this one. So I've got 6, 18, 24, and 30. So let's see if this is a geometric sequence. If it is, I can take my second term and divide it by my first. I can take my third term and divide it by my second. Well, that's not going to go, is it? 18 won't go into 24 evenly, but I can reduce it. But 6 will go into 24 4 times. 6 will go into 18 3 times. Do you see how I didn't get the same value right there? So this is not a geometric sequence. Because it's not a geometric sequence, there is no common ratio. All right, kiddos, let's look at number 5. Take the second term and divide it by the first. Well, that's a proper fraction, so let's just reduce it. 40 into 40 and 40 into 80, we get negative 1/2. Now let's take the third term and divide it by the second. 20 into 20, 20 into 40. Remember, we don't put negatives in the denominator. Look, I got the same thing. Take the third term the fourth term and divide it by the third. 10 into 10, 10 into 20. I got the exact same thing every time. Negative 1/2, negative 1/2, and negative 1/2. So this is a geometric sequence. Because it's a geometric sequence, whatever I got, that negative 1/2, is going to be my common ratio. Okay? So 80 times negative 1/2 is negative 40. Negative 40 times negative 1/2 is 20. 20 times negative 1/2 is negative 10. Okay? So pause the video and work 2, 4, and 6, and you'll turn those in. All right, so in the next section, continuing the geometric sequence. So all of these in 7, 8, 9, and 10, these are geometric sequences. We need to find the next 3 terms. So in order to find the next 3 terms, we've got to find the common ratio. So take the second term and divide it by the first, and you get negative 3. If you did 63 divided by negative 21, you're going to get negative 3 because it already told us it was a geometric sequence. So my common ratio, or my r, is equal to negative 3. So 7 times negative 3 is negative 21. Negative 21 times negative 3 is 63. 63 times negative 3 is negative 189. Negative 189 times negative 3 is 567. 567 times negative 3 is negative 1,701. So by finding the common ratio, I can multiply it to each number to get the next one. And I was able to find the next 3 values in my sequence. All right, now you'll do number 8. Let's skip down to number 9. Okay, so take the second and divide it by the first. Since it's a proper fraction, I'm just going to reduce it to 1/2. And if you do the other two, 2 divided by 4, that reduces to 1/2 as well, doesn't it? So that tells me that my common ratio is 1/2. So I'm multiplying by 1/2 every time. 8 times 1/2 is 4. 4 times 1/2 is 2. 2 times 1/2 is 1. 1 times 1/2 is 1/2. And then 1/2 times 1/2 is 1/4. Okay, now if you've forgotten, 1/2 times 1/2, 1 times 1 is 1, and 2 times 2 is 4. That's where I got the 1/4 from. All right, so you'll do number 8 and number 10 here for me on your worksheet. So let's go ahead and look at the formula for a geometric sequence. So we can make a formula and find any term in the sequence. When we were doing number 7 and number 9, we were given the first 3. We found the next 3. We just went along just multiplying whatever our ratio was. But if you want to find a value on further into the sequence and you don't want to sit and multiply and multiply and multiply, you can actually use a formula, okay? And this is your formula right here. A subscript n is going to be the term that you're looking for, is equal to A subscript 1. Okay, I had a little messy writing there. I tried to write over it, but it still looks bad. That's A subscript 1 times R, which again, that's your common ratio, is raised to the n minus 1. So whatever term you're looking for, if you're looking for the 9th term, you'll subtract 1 and you'll have R to the 8th. If you're looking for the 15th term, you'll have 15 minus 1, you'll have R to the 14. Now remember, A subscript 1 is your first term in the sequence. You got to know that first term. And R is going to be your ratio. Okay? And this is your formula. So let's see what we can come up with here. Write the rule for the nth term and then find the 7th term. See how you have A subscript 7? That means to find the 7th term. All right. So we're going to first write our formula. A to the n. Okay, so it tells me I need to write down my first term. My first term is 3. And then I'm going to multiply it times R, which is going to be my common ratio. My common ratio, remember, take 9 and divide it by 3 to get 3. Or 27 divided by 9 is 3. So my R is 3. And then, according to the formula, whatever term we're finding, which is n, we'll subtract 1 from it. So this is going to be my rule to find any term in this sequence. But then it asks me, after I've made my rule, to go ahead and find the 7th term. So we're going to find the 7th term. So we'll have 3 times 3. Well, what's my n now? It's 7. So I'm going to have A of 7 is equal to 3 times 3 to the 7 minus 1, which is 6. Now, this is multiplication with same base, so I can add my exponents. So 3 to the first times 3 to the 6, 1 plus 6 is 7. I can take out my trusty calculator and I can multiply 3 to the 7th power to get 2,187. Now, isn't that exciting? We wrote our own formula and then we plugged into it to find our value. It's not so bad, is it? Now you're going to do number 12, so I'm going to flip this worksheet over and look at number 13. Okay, here's my sequence. what I'm going to do is I'm going to write my formula to find any value. A to the n is equal to my first term. Remember, that first term has to be your first value. And then we're going to find our common ratio. Our common ratio has to go right here. So remember, take the second number and divide it by the first number. Well, that's a proper fraction, so I'm just going to reduce 200 into 200, 200 into 400. So that tells me that my ratio is a half. And then we'll raise that, since it's a fraction, I'm going to put it in parentheses, to the n minus 1. So this is my formula to find any term in this geometric sequence. But then the directions ask me to find the seventh term. So I'm going to replace my n's with 7's. So far, so good. So I know that 7 minus 1 is equal to 6. So now I'm going to take this and I'm going to plug this into my calculator. And my calculator is going to give me a value of 6.25. Okay? Let's look at number 15. So let's write our value, our generic formula, a to the n is equal to, let's take our second term and divide it by our first. We can take our third term and divide it by our second. Our common ratio is 4. So our first term times our common ratio raised to the n minus 1. So now we're going to find that seventh term. So negative 1 times 4 to the 7 minus 1. 7 minus 1 is 6. So we're going to multiply 4 to the 6th power times negative 1. And when we plug that into our calculator, we're going to get negative 4,096. Let's look at number 17. We're doing great here. All right, let's figure out what our ratio is. Negative 12 divided by 6, 24 divided by negative 12. So our ratio is negative 2. So our generic formula, a to the n, is equal to our first term times our common ratio, which is negative 2, okay, raised to the n minus 1. Now, we're going to find the seventh term. So 6, which is our first term, times negative 2, our common ratio, to the 7 minus 1. Notice I'm putting that negative in parentheses because that's what we do when we take a negative number and raise it to a power. So now we'll take negative 2 to the 6th power right here and multiply it times 6. You can plug that into your calculator, but when you do, you have got to put parentheses around that negative when you raise it to the 6th power, because a negative 6 times is a positive, and if you don't put that parenthesis in that calculator, it's going to make it a negative, which is wrong. So negative 2 in parentheses to the 6th power times 6, and that's going to give us 384. All right, we're making great progress. Now, let's look at our word problem. It says the table to the left shows a car's value for 3 years after it's purchased. We want to write a rule to represent the car's depreciation. So let's see. We're going from 10,000 to 8,000, 8,000 to 6,400. Okay? So what we want to do is we want to actually figure out what our rule is. Remember, a to the n is equal to, and then we're going to put our original amount, which is 10,000, times our common ratio, which I'm going to let you figure that out, to the n minus 1. So you're going to work number 19 just like you work these out up here, okay? So I'm going to let you finish up number 19 and number 20, okay? So, in summary, we've worked out all of the odd problems. You get to do all of the even problems. I know you're so very excited. Okay, so work out the even problems and send them to me. If you have any problems, just shoot me an email or send me a reminder and I'll be glad to help you out. Y'all have a great day.